The white gypsum stretches to the horizon like spilled salt, blinding under a desert sun in southern New Mexico. Wind has scoured this ancient lakebed for thousands of years, peeling back layer after layer of pale sediment. And then one afternoon, in the cracked clay of a place called Alkali Flat, a shape appears in the ground. It is the unmistakable arch of a human foot, a heel, 5 toes, pressed into mud that hardened into stone, long before the pyramids, long before farming, long before almost anything you were taught to call history. For most of a century, every textbook agreed on one number. People reached the Americas around 13,000 years ago. That number was carved in stone. And the moment scientists measured how old this single footprint actually was, that stone began to crack, because the footprint at White Sands was not 13,000 years old. It was almost twice that. And what happened next turned into one of the ugliest scientific fights of the decade. You are watching Bedrock, where we dig under the official story of ancient North America and follow the evidence wherever it actually leads. Today, I am going to take you through 3 things. First, the discovery that should never have existed according to the textbooks. Second, the brutal scientific war that erupted over whether the dates were a mistake. And third, the final piece of evidence that ended the argument and rewrote the timeline of the first Americans. Stay with me, because the resolution is stranger than the discovery. Let me set the stage with the story you were probably taught. For decades, archaeology had a king, and his name was Clovis. In the 1930s, near Clovis, New Mexico, researchers found distinctive stone spear points buried alongside the bones of Ice Age animals. These fluted points showed up across the continent, and radiocarbon dating placed them at roughly 13,000 years old. From that grew a commanding idea called Clovis First. The story went like this. As the last ice age loosened its grip, a corridor opened between 2 great ice sheets in what is now Canada. Hunters walked south through that gap, spread across 2 continents in a few centuries, and became the first Americans. Clean, simple, teachable, and for 60 years it was treated as settled fact. Understand how total that grip was. Clovis First did not live in one paper or one professor. It lived in every introductory textbook, in museum placards, in the maps printed in school atlases, with a single arrow curving down out of Siberia. Students learned the 13,000-year date the way they learned the boiling point of water. The mechanism behind it felt airtight, and that is what made it so hard to move. The Bering Land Bridge, a wide plain called Beringia, only stood exposed when enough ocean water was locked up in ice to drop the sea. Then, the ice that bridged the way also blocked the way south. 2 enormous sheets fused across Canada. The corridor between them only thawed open around 13,000 years ago. So the logic formed a closed loop. People could only cross the bridge during the deep freeze, but they could only walk south once the freeze eased and the gap melted. That timing math is exactly why 13,000 years became a hard ceiling rather than a loose estimate. And the ceiling was defended like a fortress. Any site that claimed to be older got picked apart until it collapsed. A find in Chile, another in Pennsylvania, each got the same treatment, dragged through years of suspicion over contamination or sloppy excavation. Careers were built defending the 13,000-year wall, and careers were quietly ended by challenging it. Tenure, grant money, the right to be taken seriously at conferences, all of it could ride on which side of that line a researcher stood. Reputations calcified into the model itself, so attacking the date felt like attacking the people. The contrast is almost cruel. A model that started as a reasonable conclusion hardened into a belief that punished anyone who questioned it. So when a team began measuring footprints in a New Mexico lakebed, they already knew the size of the wall standing in front of them, and they knew exactly who had spent a lifetime guarding it. The footprints sit in the Tularosa Basin, in the bed of a vanished body of water that geologists call Lake Otero. During the Ice Age, this was not blinding white sand. It was a shallow, marshy lake fringed with grass and reeds. a magnet for animals and the people who followed them. As the water rose and fell across the seasons, it laid down fine layers of clay and silt. People walked across that soft margin, and so did the giants of the age. Then the lake dried, the gypsum buried everything, and time pressed the prints into rock. Researchers eventually mapped thousands of these tracks, and the detail is staggering. Many of the footprints belong to children and teenagers, young people between roughly 9 and 14 years old. In some stretches, small children appear to have splashed and played in the soft mud left behind by a passing sloth. And the animals are there too, walking through the same scene. A giant ground sloth, an animal the size of a car with curved claws, drags its weight across the playa. A mammoth crosses the human path. In one trackway, the prints of a person seem to follow a sloth, and the sloth's tracks twist as if the animal reared up and turned to face something. This was not an empty wilderness. This was a crowded shoreline, full of families and monsters, frozen in the clay. But none of that is what made the world stop. What made the world stop was a question. How old is this? To answer it, the team turned to the seeds. Buried in the same clay layers, above and below the footprints, sat thin seams of seeds from a water plant called rupia, sometimes known as ditch grass. Many were still attached to their stems, sealed inside well-defined layers, which meant they had not drifted in from somewhere younger. The researchers ran radiocarbon dating on those seeds. The result landed in 2021, published in the journal Science, and it hit the field like a dropped plate. The footprints were between 21,000 and 23,000 years old. Read that again. Not 13,000. More than 20,000. These people were walking across New Mexico during the coldest, harshest stretch of the entire Ice Age, the last glacial maximum, at a time when that ice-free corridor through Canada did not even exist yet. If the dates were right, Clovis First was not just wrong. It was wrong by 8 to 10,000 years. The wall had not cracked. It had fallen. And that is exactly when the doubt arrived. Because a claim this big does not get a warm welcome. It gets a knife. The attack came in 2022, and it was aimed straight at the seeds. Critics pointed out an uncomfortable fact about rupia. It is an aquatic plant. It does not pull all its carbon from the open air the way a tree does. It can absorb carbon dissolved in the water it grows in, and the water in that ancient lake may have carried dissolved carbon from old limestone and groundwater. Carbon that was already thousands of years old before the plant ever touched it. This is called the hard water effect, or a reservoir effect, and it does something dangerous to radiocarbon dating. It makes a sample look far older than it really is. If the lake water was loaded with ancient carbon, then the seeds could have inherited that false age, and the real footprints might be thousands of years younger. Some skeptical estimates push the prints back toward that familiar window of around 13 to 15,000 years, right back behind the old wall. The stakes here were enormous. If the critics were right, one of the most famous discoveries in American archaeology was built on a measurement error. The team had to answer, and they could not answer with the same seeds. They needed something that water could not contaminate. But the seeds were never going to be the real ending, because the doubt was only the first surprise. The team did not retreat. They went back to the lakebed and attacked their own dates from two completely independent directions, using materials and methods that had nothing to do with aquatic plants. The whole point was to remove the reservoir effect from the equation entirely. If a water plant could absorb old carbon, then the obvious move was to date something that never lived in the water at all. And there was something hiding in those same layers, almost invisible, that fit the job perfectly. Pollen, specifically the pollen of pine trees, conifers that grew on dry land in the hills around the basin and drifted down into the lake by the millions. A pine tree breathes air. It does not sip from the lakebed. Its carbon comes from the atmosphere, clean, with no hard water contamination possible. The problem was practical. A single pollen grain is microscopic, and you need a huge amount of carbon to run a reliable date. So the team did something almost absurd. Using a technique called flow cytometry, they isolated and counted out roughly 75,000 individual pine pollen grains per sample, sorting them one by one until they had enough terrestrial material to date the layers directly. And the pine pollen agreed with the seeds. That agreement carried real weight, because the two clocks measured different worlds. The seeds had grown with their roots in the lake. The pine pollen had blown in on the wind from dry slopes that never touched the water. A pine on a hillside drinks only from the air, so its carbon clock starts the moment it forms, with no ancient lake carbon to drag the age backward. That is precisely why dating terrestrial material sidesteps the hard water problem that had haunted the seeds. The poison everyone feared lived in the water, and the pollen had never been near it. When that land-based clock landed on the same number as the water-based one, the reservoir argument lost its footing. But the team had a second, totally separate weapon, and this one did not use carbon at all. It is called optically stimulated luminescence, and it measures something completely different. Grains of quartz sand, buried in the dark, slowly absorb radiation from the soil around them and store it like a tiny battery. The clock starts when the grain is last exposed to sunlight, because light empties the battery. So if you can measure how much energy a buried quartz grain has stored since it last saw the sun, you can calculate how long it has been buried. No plants, no lake water, no carbon at all. The team pulled quartz from the footprint layers and ran the luminescence dating, and it returned a minimum age of around 21,500 years. Now line up all three. The original rupia seeds said 21 to 23,000. The pine pollen, immune to hard water, said the same. The quartz luminescence, immune to carbon entirely, said the same. Three independent clocks, built on three different physical principles, all pointing at the same window. The 2023 study in Science laid it out plainly. The pollen ages and the luminescence ages were statistically indistinguishable from the seed ages, every one of them sitting inside that 21 to 23,000 year range. The reservoir effect, the one weakness everyone had pinned their doubt on, simply was not there. The dates held. So step back and feel the size of what that means. The textbook said the first Americans showed up around 13,000 years ago, after the ice retreated and opened a path. White Sands says people were already here, raising children and tracking giant sloths across a New Mexico lake bed at least 21,000 years ago, in the very depths of the Ice Age, when the supposed entry route was still sealed shut by ice. Clovis first does not just lose a few thousand years. Its entire mechanism breaks. If people were south of the ice sheets that early, they did not stroll down a corridor that had not opened. They got here some other way, and they got here far earlier than anyone was allowed to say out loud for 60 years. The footprints do not merely push a date backward. They tear out the foundation of the whole story and force a question that archaeology is still scrambling to answer. Who were these people? And how on earth did they arrive in the heart of a frozen continent long before the door was supposed to open? And underneath all the dating methods and the scientific war, there is one image that refuses to let go. Strip away the journals and the carbon and the quartz, and you are left standing on a marshy shore more than 20,000 years ago. A teenager walks across the wet clay carrying a small child, setting the child down now and then, picking it back up, the toddler's tiny prints appearing and vanishing beside the larger ones. A giant ground sloth lumbers across the same ground, and for a moment the human tracks and the animal tracks cross, two living things sharing one muddy afternoon. Children splash through the puddles, a sloth left behind, the way children have always played in mud. None of these people knew they were making history. They were just trying to get across the lake before dark. And every step they took pressed down into clay that would harden into stone and wait, silent, for 20-something thousand years, until the wind peeled it open and a stranger knelt down and understood. So here is where it lands. The 13,000-year wall that ruled American archaeology for most of a century is gone, not because someone wished it away, but because three different clocks all read the same impossible number. The first Americans were here far earlier and far stranger than the textbooks ever admitted. which means the real story of how humans reached this continent has barely been written. So I want your honest take. If people were already walking through New Mexico more than 20,000 years ago, with the ice corridor still closed, how did they actually get here? By boat down the coast, by some route we have not found, or by a story we have not imagined yet? Drop your theory in the comments, because this is the kind of question that gets solved in the comment section as much as the lab. And if you want to keep walking these vanished shorelines with me, where the ground itself keeps overturning the official story, subscribe and stay on Bedrock. The next footprint is always older than they think.